First thing in the morning, you open your eyes, but what do you see? Well, phototransduction is the conversion of light into neural impulses. The powerful computer that we call a brain receives electric signals from our eyes as they take in light waves. The colors you think you see are limited to your brain's light perception. For example, the human brain can interpret light on the ROIG-BIV spectrum, yet bee brains only form blue-green, blue, and violet. Our brains work similarly to computers. When you press the A on your keyboard, it recognizes the stimuli and sends multiple electronic codes to different processors at the same time, allowing it to portray the multiple aspects of the image as one. Much alike, the brain processes color, movement, form, and depth in different areas at the same time and interprets it into one image. This is called parallel processing. In the occipital lobe, located on the back of your head above the base of the neck, your visual sensations are processed in a place called the visual cortex. While this process is a major part of perceiving vision, the eyes themselves play a large role as well. Due to something called retinal disparity, it receives two slightly different images from each eye and processes it into one. Here's how your brain and eyes work together step by step to perceive the image before you. Step 1. As we open our eyes in the morning, light reflecting off the ceiling, or whatever you wake up to, enters your eye via the cornea, which bends the light. It then travels through the aqueous humor, a liquid substance that sits behind the cornea. Step 2. Continuing on its journey to your brain as the light passes through your pupil, the colorful part of your eye, also known as the iris, contracts to let light in, dependent on its brightness. Step 3. The light's next stop on its path to perception, just past the pupil, is the lens, which once again bends it, effectively flipping the image upside. The inverted light then swims through a clear gelo-like substance named vitreous until it washes up on the retina. It then focuses on this light-sensitive layer containing photoreceptors, which are nerves made of rods and cones. Essentially, the solar panels powering our vision, they are responsible for turning light into electrical impulses. This is where phototransduction, which you might remember me mentioning in the beginning, occurs. If you do, and you've made it this far, please leave a like and let us know in the comments below what topics you'd like to learn about next. Anyway, in the fourth and final step, after all of the electric impulses have been collected from the light by the retina, they make their way through the optic nerve toward their final destination to be processed, the occipital lobe. While it's the smallest of the four lobes, a lot occurs in this part of your brain, such as visuospatial processing, distance and depth perception, color creation, object and facial recognition, and visual memory formation, all of which are imperative to creating your perception. I should mention, this is the standard process for sight. However, every human being's experience is unique. You and I can only truly understand things we have perceived firsthand. But thanks to pictures like this and stories from those afflicted, we can be grateful not to know exactly what prosopagnosia or face blindness feels like. It can be a symptom of Alzheimer's, dementia, or any brain damage, but it can also be a lifelong condition starting at birth. If you are interested in learning more about brain disorders and how they work, there will be a more in-depth video coming soon. In the meantime, let me know in the comments if you know someone afflicted with face blindness, or if you have any questions I can answer in the next video. Subscribe and hit the bell to stay in the loop.